These notes are going to cover your graphing cubic functions, and we're going to do that through the same way that we talked about quadratics. So what we're going to do is first go through and get the parent function of the cubic graph. So like the quadratic parent function for the cubic, our parent table is going to revolve around 0. So we want to pick the easiest numbers to cube that are less than 0 and more than 0. So those would be small integer numbers. So very much like the quadratic, our table is going to include -2, -1, 0, 1, and 2 as the x values. For the y values of these, since this is a cubic, you're cubing them. So -2 cubed would be -8, -1 cubed, -1, 0 would give us 0, 1 would give us 1, and 2 would give us 8. Now we want to plot those on our graph. And this will make our cubic shape. You can see on this graph that our HK values are 0, 0, which is also where our graph intersects the x and y axis. So those are our x and y intercepts as well. The domain for this graph, since it has no stopping points or turning points, is all real numbers for both domain and range. And on this graph, as I travel over the graph to look at the increasing and decreasing intervals, as I trace this graph, the entire time I would be going upward as I traveled from left to right. So that means the entire graph is increasing. So the increasing interval is the entire domain, which is -infinity to infinity. And there is no decreasing interval because the graph has no distinct turning point. This graph is 1-to-1. The rate of change varies because the pieces are not linear, they are curved. And because it doesn't have a place where it turns around, it has no minimum and no maximum value. So now we're going to go through and we're going to do a couple of examples. So the first example we're going to look at, and you only have space on your paper to write one of them. So why don't we walk through the first one together, and then you guys could write down the second one if you wanted, or you can rewind and go back to the first one if you decide you prefer that. So if we had this cubic, sorry, that should be cubed, -x plus 6 cubed minus 4. This means we're going to start with our parent function, which is -2, -1, 0, 1, and 2 for the x's, and they're cubes for the y's. But we're going to transform them. So x's are going to get shifted left 6 due to our h value of -6. Y's are going to get reflected and shifted down 4. So I'm going to take each x value and subtract 6 to give me a new list of x values. And I'm going to take each y values opposite and subtract 4 in order to give me a new list of y values. So this table of points is what this new graph will look like. So then I'm going to go ahead and plot those points. And the -4, -12 is a little off my graph, but I can still understand where that is. And this is what my graph will look like. So now the h and k for this was -6, -4. And to find the x-intercept, I'm going to have to set y equal to 0. So I'm going to use this space off to the right to set y equal to 0. And then I would add 4 to both sides. I'm working on getting the cubed portion alone, and then divide by -1. So I would have that -4 is equal to x plus 6 cubed. And to get rid of that cube, I'm going to want to cube root both sides. Now, you can take the cube roots of negatives, and there's no mystery here. So there should be no plus or minus like there is with square roots. And the cube root of a negative number will result in a negative. We don't know the cube root of 4, so we're just going to write it as the cube root of 4. So the cube root of -4 is a negative cube root of 4. And then I'm going to write x plus 6 on this side. And my final step will be to subtract 6 from both sides. in order to have what x is equal to. So my x-intercept is -6 minus the cube root of 4. For my y-intercept, I'm going to plug 0 in for y. And this might not be simple, but it's a little bit easier than calculating the x-intercept due to the fact that everything's already on one side with y alone. So we're going to calculate here first and get 6 cubed, which is 216. And negative 216 minus 4 is negative 220. So my y-intercept is negative 220. And again, because the graph has no turning points, both the domain and the range are all real numbers. And this graph, as I look at it from left to right, is kind of falling. So it has no increasing interval, but the entire domain from negative infinity to infinity is a decreasing interval. It is 1-to-1. The rate of change varies, and there's no min and no max. Okay. We're going to look at one more, and that will be it. So the last equation we're going to look at, we'll just make the numbers a little more difficult here. We're going to have a 1/3 x plus 4 being cubed minus 1. So here, our transformation table, again from this cubic parent function, is going to have a shift left of 4 due to the h value of -4, a vertical compression of 1/3, and a shift down 1. And so I'm going to take each x value and subtract 4 from it to have the new locations horizontally. And I'm going to take each y value, times it by 1/3, and subtract 1 to get the new vertical distances. Oops, sorry about that. I wrote that parent function wrong, so let's make sure we fix it. All right, so these points will give us our new graph. So -6, -11/3, which is like -3 2/3, -5, -1 1/3, -4, -1, -3, -2/3, and -2 5/3, which is like 1 2/3. And so I'm going to draw that curve in and fill in those characteristics. So our h and our k were -4, -1. And again, for our x-intercept, we're going to have to go through that solving process where we set y equal to 0. So I would add 1 to each side, and then times by 3 to cancel out the 1/3. And then at this point, I would want to cube root both sides. Again, no plus or minus needed with our cube root, and I would have the cube root of 3 equals x plus 4. And so x will equal -4 plus the cube root of 3. And I will write that as my x-intercept. For my y-intercept, I will set x equal to 0. So I'll have 1/3 multiplying 64 minus 1. So that will be 64 over 3 minus 1, which I'll think of as 3 over 3, which would give me 61 over 3 as my y-intercept. Again, our domain and range with no turning points are all reals, and this graph, as we look from left to right, increases continuously. So the entire domain is an increasing interval with no decreasing interval. It is 1-to-1. The rate of change varies, and there's no minimum and no maximum. So these notes should help you with your skill on graphing cubics with transformations. You should have this check-in quiz and your review that you can be working on.